Welcome to AI and the Language Frontier, Breakthroughs in Computational Linguistics. Today, we explore insights from 53 cutting-edge research papers in computational linguistics. The focus is on how machines understand, generate, and sometimes misunderstand language, with special attention to reliability, safety, and the evolving role of language models. Stay tuned for our paper of the day, Decoding Memories by Weizhi Gao and colleagues, as well as practical impacts and future directions in this dynamic field. Artificial intelligence can display surprising behaviors, sometimes for better, sometimes for worse. For instance, an AI's verdict on content quality can shift by 50% simply by changing the author's name. While language models excel at tasks such as passing medical exams and composing poetry, they are also prone to inventing facts with confidence. Some models are easily misled by subtle tricks or can alter responses based on labeling. Computational linguistics uncovers both the remarkable capabilities and the persistent blind spots of these systems. In this episode, we delve into these unexpected findings and discuss what they mean for researchers, developers, and everyday users. The significance of computational linguistics is profound. Language technology is at the heart of search engines, virtual assistants, translation services, and beyond. Recent research addresses challenges like hallucinations, safety, and ensuring fairness in real-world scenarios. This episode highlights major breakthroughs, the motivations behind them, and the ingenuity that drives researchers forward. By understanding how today's language models shape tomorrow's interactions, listeners will embark on a journey from fundamental challenges to innovative solutions. To appreciate the field, imagine an airport bustling with announcements, changing signage, and conversations in multiple languages. Computational linguistics acts as the GPS for artificial intelligence, guiding machines through the complexities of human language. By blending computer science, the engine, with linguistics, the fuel, this discipline enables machines to comprehend, generate, and interact with natural language. Applications range from virtual assistants and translation tools to medical record analysis. The challenge is akin to teaching a robot not only to read and write, but also to participate in genuine, real-world dialogue. The rise of large language models, or LLMs, is a defining trend in computational linguistics. Almost every recent study centers on these systems, probing their capabilities as well as their vulnerabilities. A key concern is hallucination, the phenomenon where models confidently invent information. Researchers also examine threats, such as orthographic attacks, in which adversarial agents subtly alter written text to deceive models. Han Yang's team, for example, developed pixel-based defenses to detect these disguised changes, analogous to training autocorrect systems to recognize both simple typos and more sophisticated malicious tricks. Robustness and safety are central themes in recent research. Investigators prioritize making AI systems resilient against attacks and neutralizing hidden backdoors. One innovative approach, LETHE, introduced by Chen and colleagues, dilutes malicious knowledge by blending compromised models with clean ones, an approach likened to flushing poison with fresh water. This increases safety without sacrificing performance. The pursuit of robustness is similar to constructing a lock that becomes stronger after each attempted breach. A technical focus is placed on mitigating backdoor attacks, where hidden triggers can provoke undesirable behaviors in otherwise reliable models. Evaluation and benchmarking methods are evolving rapidly to keep pace with increasingly complex AI systems. New test suites, such as UiBench and Percept-V, assess models on tasks ranging from realistic web interface generation to basic visual understanding. Muskan Saraf and co-authors identified a notable issue, label bias. where the label assigned to a model can significantly sway human judgments, sometimes by as much as 50 percentage points. These findings reveal how models' self-evaluations and human evaluations can be surprisingly sensitive to presentation. Blind benchmarking, akin to blind taste tests, is essential for ensuring fairness and building real-world trust in AI systems. Several key findings and breakthroughs stand out from the recent literature. The Decoding Memory Pipeline developed by Weizhi Gao and collaborators dramatically reduces the time required for hallucination detection. LETHE from Chen Chen's team decreases backdoor attack success rates by up to 98% without compromising model performance. The R*2 agent, as described by Zhang and colleagues, achieves strong results in math and science tasks with fewer computational resources. Serif's work reveals that model labels can bias evaluations by up to 50%. Meanwhile, the MSRS benchmarks demonstrate that models designed for reasoning, rather than mere retrieval, excel at synthesizing information from multiple sources. The featured paper, Decoding Memories by Weizhi Gao and colleagues, addresses a critical problem. Large language models sometimes invent facts, posing risks in domains like healthcare and finance. Traditionally, hallucination detection involves generating multiple answers and checking for self-consistency. But this process is repetitive, slow, and expensive, especially with large models. Gao's team reimagined the process, focusing only on regenerating the parts of answers that differ, thereby enhancing both speed and efficiency. The Decoding Memory Pipeline, or DMP, operates by tracking common and repeated segments in model responses. Rather than regenerating entire outputs, DMP only produces new tokens, those segments of text that genuinely add information or reflect differences. This is comparable to an editor who reads only the new paragraphs in each draft, rather than rereading the same introductory language. Importantly, DMP is a plug-and-play solution that can be applied across different models and datasets. In technical terms, a token refers to the smallest unit of text a model generates, and DMP targets only those tokens that require attention. DMP delivers substantial benefits in speed and reliability. Hallucination detection becomes up to 3 times faster, all without loss of accuracy. This enables real-time checks, which are crucial for ensuring safer AI outputs in sensitive applications. The approach originated from close observation of actual model behaviors, highlighting how significant gains can arise from attention to small details. DMP sets a new baseline for the efficient and trustworthy deployment of large language models and serves as a reminder that valuable insights often emerge from questioning established routines. Looking forward, the field of computational linguistics is undergoing a strategic shift. The focus is moving away from simply building larger models toward developing smarter, more scalable infrastructure. Efficiency, security, and domain-specific solutions are becoming priorities. Robust evaluation and fairness are now central concerns rather than optional features. Multimodal and collaborative AI systems, those that can handle text, images, audio, and more, are increasingly prevalent. This evolution can be likened to upgrading a city with smarter roads and bridges instead of just constructing taller buildings. In summary, the landscape of language AI continues to evolve rapidly. Computational linguistics now shapes how people search for information, learn new topics, and connect with others. The 53 papers reviewed reveal progress in speed, safety, fairness, and trust, but persistent challenges remain, including bias, security threats, and the quest for genuine understanding. Creativity and collaboration are the main drivers of steady advancement. Listeners are encouraged to explore the referenced papers, share their insights, and actively contribute to shaping the future of this vital field. This presentation was created through a synthesis of advanced AI tools and human expertise. Slide content was generated using GPT 4.1 by OpenAI for language and reasoning tasks. TTS synthesis was provided by OpenAI, and image generation for visuals was handled by Google. All content was reviewed and refined by human experts to ensure clarity and technical accuracy. The complete list of references from the arXiv preprint server, dated August 28, 2025, is available in the show notes. Please note that while every effort was made to ensure accuracy, some oversights may remain. Always consult the original papers for definitive information. Thank you for joining the AI Frontiers community. Subscribe to AI Frontiers for regular deep dives into the latest research. Gain early access to expert interviews, paper summaries, and more. Share your favorite insights and questions in the comments, and find all references and bonus resources in the episode description. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.